Hello, welcome to my channel. Welcome to Practical Electronics 3. In our previous practical, we covered transistors, BJT transistors, how transistors work, and how current flow through a transistor, where we also covered how to read the polarity of an NPN and a PNP transistor using our digital meter. Then we demonstrated how current flow through a transistor. So in this practical, we are going to be dealing with real life practical application of transistors. We're going to design a circuit to drive a DC motor. The circuit is a DC motor driver using BJT transistors. We also have another version where we will incorporate a MOSFET, metal oxide semiconductor field effect transistors, also to drive DC motor. So let's start right away. So welcome to Practical Electronics 3. In this practical, we are going to be dealing with real-life practical application of transistors. In our previous practical, we've covered how transistors work, the BJT, NPN, and PNP, how to read the polarity of the NPN and PNP transistor using our digital multimeter. In this practical, we'll be dealing with the application, the real-life application of transistors. Here we have two circuits here. The first one is a transistor DC motor driver using BJT, that's bipolar junction transistors. So here is our circuit in figure 1. Here you can see we have 3 transistors here. We have an NPN transistor here, C945. If you can use any NPN transistor. Then we have another one, PNP, A950. Then we have another one here. I use the 13005. You can use any transistors you have. Now look at the circuit very well. Here is where you connect your DC motor, the positive and the negative going to your DC motor. Here's a power supply 12 volt. You know, the motor we are talking about operates from 12 volt DC motor. So now we are using an NPN transistor here. Now the current rating of this transistor, make sure it should be able to handle the current rating of the motor. So make sure the transistor we are using here, the current rating should be far higher than that of the motor. Look at this here. Now from our previous practical, we know that we activate an NPN transistor using positive signal. You activate a PNP transistor but using negative signal. That is a positive voltage. We activate an NPN transistor, while negative voltage will activate a PNP transistor. Now look at this circuit here. Here is our input, the signal input. Either you can input a digital signal in or even an analog. You understand? Now there is no signal in here. At this point, we don't want the transistors to be conducting. So from this arrangement here, this 10K resistor is going to bring the base of the transistor to 0 volts, so there will be no voltage, so that it won't be floating. Then here we need a base. You know, our previous practical, you don't just connect signals straight directly to the base of the transistor without current limiting resistor. So we have a 1K current limiting resistor here. So when there's no signal, we have a zero voltage at this point. So at this point now the transistor is off. So which means this collector and the emitter terminal is of high resistance, infinity. The terminal is open. You understand? Then at this point here, this is a PNP transistor. We need a negative this in here to turn off this transistor. Why here we need positive to turn it off? Now we have a 10k resistor here. There's going to be voltage at this point. So at this point now this transistor is going to off. There will be no voltage coming out here. You understand? Also, when linking transistor this way to ground, if I remove this transistor here and I connect this to ground, this transistor is going to turn on. So the same way we put current limiting resistor at the base, the same way we put current limiting resistor here at the base of this transistor. You understand? This 10k resistor is to make sure that this base of this transistor is high. While here this 10k resistor is to make sure that the base of this transistor is low. You understand now? Now look at this transistor. This is sinking. This is operating in current sinking mode. This and this, they are sinking. While this one is sourcing. You understand? This one is sourcing current. While these two are sinking. So current flows this way to your DC motor and then comes out through to this point. This transistor is acting as a switch. You understand? Now, if this transistor is off, this one is also going to be off. This one is also going to be off. Now, if we put in a signal here, let's say we put in 3 volts or 5 volts here at this point, this transistor will conduct. It means it is going to pull the base of this PNP transistor to ground, which will now make this transistor to now conduct. But this transistor now is pulling the base of this to ground to 0 volts. So this transistor will conduct and this transistor will bring out some voltage, and then it will turn on this transistor here, which is driving the DC motor. So you see, so that's how the entire circuit works. So if you look at this, the direction of flow of current flow this way through the motor, it comes through this way to ground. You understand? This way to current flows through transistor this way and then out. Now, if there is no signal here, this transistor goes off. This one also goes off. Make sure we also have the same setup we have here to make sure this point also there is 0 volts here. So to make this one to be completely off so that we don't have any parasitic voltage on this. So you can look at it. So let's now let me show you our second circuit before we go to the practical. Look at the second circuit here. Transistor DC motor driver using BJTs and MOSFET. MOSFET stands for metal oxide semiconductor field effect transistor. You understand? So now look at the first circuit very well. Observe it very well. The only thing we are changing here in the second circuit is this one, the MOSFET. So look at the second circuit here. So look at it. It's the same thing. Here we have a MOSFET. Now MOSFET handles very high current. You understand? This MOSFET here, you can see. You can use any of this MOSFET. The one I use here is this, which is 50 amps. So you see. So MOSFET operates just like almost like the digital. You understand? So if this place is high, the MOSFET will turn on. So here, now look at let's go back to our BJTs. In our BJT transistor, this is our base, this is our collector, this is our emitter. Now when you go to the MOSFET, the polarities are gate, drain, and source. Now look at this diode here. Observe let's go back to the first circuit. Why is this diode here? Why putting this diode? Now you are driving a DC motor which has coil, which operates with the principle of electromagnetism. So if you don't put this diode here, turning on this motor rapidly, turning off rapidly, the coil, there's something called back EMF, electromotive force. That's the voltage that can be generated from the coil of this motor. It can destroy this transistor, which I have practically confirmed that. So that's the reason why we put, when you are driving anything that has to do with coil, make sure you put a blocking diode there. Here I use 1N4007, so to block the back EMF that will destroy this transistor, to prevent the the voltage that is being produced by the coil not to destroy this transistor. So let's go to the circuit. So look at the circuit here. The only thing we remove here now, this diode here is not just necessary. Now the MOSFET have inbuilt diode. You understand? The MOSFET have inbuilt diode. This particular one we are using is called N channel. This N channel. We also have P channel. If we check, look at the direction of the arrow. If it's a P channel MOSFET, the direction of the arrow will be opposite. It's just like the way we have the direction of arrows on the BJTs, PNP. Look at the direction of the emitter, the arrows, they are opposite. So this is the this is the best DC motor transistor DC motor driver I have been able to design, and it's working very well for me. You understand? Now you can design yours in various ways you wish, but for me this is the way I design. I'm using it on real life device. So let's go to the practical. Let's go to our practical here. So let's so look at this NPN transistor. This is a PNP. This is also NPN. Now this wire is where I'll be feeding in signal. You understand? Now I'm going to give some power supply. I'm going to power the board. So the board is on. So this is our DC motor. This is our DC motor. So look at our DC motor here. So if you observe our circuit very well, look at the circuit. Our DC motor is at this point. So this point here, this terminal is 12 volts. This terminal is our ground. So I have 12 volts supplied here. Let's check the voltage from our meter. So you can see the voltage here at this point. Now let us now look at this. I'm going to take this and touching. You can see our motor is running. Just feeding some signal. You can see our motor is running, and I take it off. The motor goes off. So you see. So at this point, the motor is completely off. There is no signal here. There is no signal. So you see. So at this point, the motor is completely off. Now, this is the NPN transistor, power transistor. No, we call this power transistor. This is the one. This one is handling the load. That's what it does. It handles the load. So here, let's take this off and connect it to our MOSFET. So we take the negative terminal for our DC motor, and we have connected this, the second circuit now. So my input touch it. You can see. So you can see both circuits. This one we have added a MOSFET. So this will handle higher current, heavy DC motor that run on 12 volt. You understand? You can handle with this. So you see. So let's see how we're going to. I'm going to feed in this point now from the output of a microcontroller. So let me bring my this my Arduino Nano. I have a look at this. This is infrared remote control. Now this is the output from this is the PWM. I'm going to be using this pin now to control this motor. So let's connect the circuit. This is the ground from this other circuit. I'm connecting it to the ground of this circuit, to the ground terminal. Now when you are connecting two circuits together, this side now is one with the microcontroller. You understand? So so this is what we want to use microcontroller now to be able to what control the DC motor. So this is the PWM pin from pin 5. This pin that you're seeing here, this is from pin 5. So it's PWM. So this is the signal from the DC motor driver. So I'm taking this now, connecting it to pin 5. You can see. So I'm going to power the microcontroller board. So I'm going to feed in some voltage. So the circuit is on. So I'll be controlling the circuit from a remote control. You understand? So now let's see. Look at our DC motor. So I'm using this to operate it. So you can see. So So you can see now I'm going to be increasing the speed of the DC motor by pressing these two arrows. So you can see the speed is increasing. You can see. Press this down, I'm going to be reducing the speed. So observe the DC motor very well. You can see the speed is coming down. So you can see. So observe the DC motor very well. So you are seeing it. So you can see. So you can see. I'm going to turn it off from the remote control, pressing this zero button, we're going to turn the motor off. So you see, so this is a practical application. So this was the program that I wrote for uh, controlling the DC standing fan. So you can see, so where I'm using remote control now, you can see our motor is off. The driver, the MOSFET. So you can see how we can control DC motor using transistors. So this is practical real life application of transistors. So what we learn theoretically, we apply it in real life. So if you are using DC motors and you want to be controlling the speed, you understand, controlling the speed like a DC fan, this is the best circuit that I've come up with, and it's working very well for me. Now if your motor is a bigger one, you need to attach an heat sink. So this is a small motor we are using for demonstration here. I will show you the one that I did for my friend, how I apply the circuit to controlling the DC standing fan. The DC standing fan comes with a bigger motor. I'm just using this to demonstrate, to test the circuit, so you can see. So now I also made this in a way that I have 4 speed levels. If I press, now look at the motor, I'm going to press number 1 on my remote control. You can see. I'm going to press number 2 on my remote control. I'm going to press number 3 on my remote control. You can see the speed. I'm going to press number 4 on the remote control. You can see it's running at full speed. You see, then I'm going to press 0. You understand? So you understand. Now here, I'm using software, the C program, Arduino, called Arduino C program I've written here. This is a microcontroller. You understand? So I'm using software now to control this DC motor through the DC motor driver. So you see, so at this point now there is no signal. At this point there is no signal coming out from our microcontroller pin. So at this point the motor is completely off. There is 0 volts going in. Now let's confirm the volt. Let's connect a multimeter to check the voltage of the DC motor. We're going to connect our digital multimeter. So we'll connect this to our positive. Let's connect this to positive line, and then this to the negative terminal of the motor, so that we can monitor so I could check the voltage. So you can see, so what I'm seeing here, you can see there is no voltage, 0 volts. So you can see. So let's turn on the motor. I'm going to turn on the motor gradually. You understand? I'm going to turn on the motor while we take a look at the voltage. So be looking at the voltmeter. I'm going to turn on the motor gradually using the remote control. So look at the voltage we are seeing there. So you see, I'm going to be increasing the voltage gradually from the remote control. So let's be watching the voltmeter. I'm increasing the speed gradually from my remote control. So you see, so you can see the voltage is increasing as well as the speed of the motor. You can see it. I'm increasing the speed of the motor and also the voltage. So you can see we have entered 5 volts. So you can see I'm gradually increasing the speed of the motor as well as the voltage. So you can see it. Increase in the voltage will lead to increase in the speed of the motor. So you see, increasing the speed of the motor gradually as well as the voltage. Now let me run this at full speed. I'm going to press number 4. So you can see the voltage. So that's the maximum voltage. You can see. If you check out my power supply, I'm using, look at my power supply, look at the voltage from my power supply. See, it's 11.6 volts. So you can see. So you can see with this MOSFET, the voltage drop is just very small. You see, the voltage drop is just very minimal. So you can see how good the circuit is working. So you see, if you check from the, so if you look at the voltage from my power supply here, which I built, to rechargeable power supply which I built. So look at the voltage here, then look at the voltage from our multimeter. So you can see the voltage difference. The voltage drop is all very minimal. So you can see. So we see. So MOSFETs are very good in handling heavy current. So there is the resistance between the gate and the drain is very minimal compared to an NPN transistor. So that's why we use them for switching heavy loads. So you see. So I'll be showing you the DC fan which this circuit here is applied. The DC fan I'll be showing you later. So let's turn it off. So you see 0 voltage to the motor. So to tell you how efficient this motor driver circuit is, you understand. Now we also have other versions of this device that uses motor. This is also another. This is a module. This is a module also for motor driver. Now, if you have a situation where you want to be driving the motor in both directions, and you don't want to build yours from scratch, you can buy this module. This is a 2-channel DC motor driver. Yeah, this one can handle 2 DC motors. 2 DC motors. So you see, you can reverse the motor in both directions. So you will need a module like this. These are the digital inputs that goes to your microcontroller. This is where you connect your first motor and the second motor. For example, if you are going to robotics where you have 2 wheels, one wheel on this side, another wheel on this side. So you connect the motors controlling each of the wheels. And then you have 4 inputs here which goes to your microcontroller. So digitally, so this uses an IC. This is an IC integrated circuit. Now, the foundation of this modern electronics is based on transistors. There are actual transistors in this IC. The design of this, the actual transistors, what we are seeing here, are inside of this. So transistors is the foundation of modern electronics we have today. Transistors. So there is no how integrated circuit will be developed without these transistors. So you can say, so this is also a DC motor driver. You understand? So it's a module, DC motor driver module. Now this one is 12 volts. You can put in 12 volt here. This is your power supply, 12 volt and ground. You understand? 12 volt and ground, and then here is 5 volt. So here are the input, these two are the output to the motor. So you could also have something to try and get something like this. So uh so this is the end of this practical. So you can go and try this at home. Go and try this. Uh go and try this. So let's go on to I'll show you. Let me show you the DC fan where I use this circuit.